Many project teams mistakenly believe a facility is commissioned the moment the equipment is installed and energized. Commissioning algorithmically closes operational risk through a continuous evidence chain that begins at design and ends at handover. The level gates, CxL0 to CxL6, halt progression until validated evidence is provided. An evidence block must slot into the gate to advance. Above, owners and engineers validate this evidence. Pushing forward without raw data compromises the project's integrity. When standards from the owner, the manufacturer, or local authorities conflict, the most stringent requirement applies by default. Any deviation from this rule requires a formal, approved technical justification. A facility costing hundreds of millions of dollars is only as reliable as the paper trail proving its capability. Without that continuous chain, the infrastructure cannot be trusted to support a live load. Field execution relies on a strict color-coded tag system to enforce the evidence chain. Every asset must progress through red, yellow, green, blue, and white status. The CxL2A Red Tag confirms the equipment is delivered, anchored, and has passed its initial installation QA. At this stage, energization is strictly prohibited. A Conditional Yellow Tag provides a restricted, temporary exception for specific testing, like valve actuation. This is a controlled safety permit, not a method for bypassing static testing requirements. Individual equipment startup and pre-functional readiness are confirmed at the CxL3 Green Tag stage. The CxL4 Blue Tag validates the performance of the entire system, providing the data required to prove capacity and functional response. Bypassing these gates allow unseen defects to remain in the infrastructure. This renders subsequent reliability tests inaccurate and places the future operational foundation at risk. Standardized nomenclature prevents catastrophic switching errors by ensuring every operator identifies the same voltage class on every drawing and permit. In this AB critical power path, the 150 kilovolt incoming utility lines are classified as high voltage, or HV. The 20 kilovolt switchgear and distribution lines are classified separately as medium voltage, or MV. Mixing these naming conventions invalidates safety permits and isolation criteria. Full acceptance requires proving both the physical power delivery and secondary telemetry. The raw current and EPMS data must be validated as distinct concurrent evidence chains. Major electrical packages require specific evidence based on their design. Oil-filled transformers must pass containment and Buchholz relay tests, while dry-type units require resin inspection and thermal stability proof. Battery systems cannot pass commissioning without capturing raw baseline data. This provides operations with the necessary reference point to track cell degradation over time. Load bank testing is considered invalid if the temporary heat rejection path and emergency stops are not commissioned in tandem with the electrical draw. An electrical path is only secure when the telemetry, baseline data, and failsafes are proven to operate simultaneously with the power delivery. Mechanical commissioning evaluates cooling as a continuous heat rejection chain, moving from the heat source to the ambient environment. The SPLC state point map charts thermal energy flow from S1, the IT heat source, through the CRA and chilled water loops until it reaches S6 for ambient heat rejection.
This chain creates absolute hold points. No pumps can be started until the pressure tests, pipe flushing, and water treatment evidence are formally accepted. Functional performance testing at CxL4 is prohibited until design flows and valve positions are recorded. For direct-to-chip liquid cooling, the state point map branches into a clean secondary coolant loop managed by the CDU, physically distinct from facility water. CDU acceptance requires proof of stable coolant delivery to the rack and a verified automated response to leak and power faults. Validating the control actions across the entire interconnected state point chain provides the only accurate proof of thermal stability. Moving to the CxL5 White Tag gate requires proving integrated behavior. Individual component functionality alone cannot guarantee the survival of a mission-critical facility during a failure. The Integrated Systems Test, or IST, introduces controlled disturbances to prove the infrastructure survives cross-discipline failures. Every IST script follows a 7-step format, beginning with a pre-brief to establish safety protocols and a stable baseline for all system trends. The trigger simulates a utility loss. During the observe step, human intervention is forbidden. Automated systems must independently detect failure, transfer load, and re-engage cooling. Systems hold this failure state to measure thermal impact before the restore phase returns the facility to normal. Resilience evidence is categorized by the project's compliance target, specifically Tier 3 concurrent maintainability or Tier 4 fault tolerance. Tier 3 evidence requires a demonstration that any single power or cooling path can be manually isolated for maintenance without impacting the critical IT load. Tier 4 evidence requires the facility to automatically survive an unplanned failure across active power or cooling paths without any loss of capacity. Ultimately, documented and measured behavior under extreme operational stress provides the only reliable proof of true data center resilience. Transitioning to CX Level 6 ensures that the operations team has the knowledge and data required to securely manage the facility. The integrated CX item register identifies any gaps between discipline boundaries, such as missing test packs or unresolved safety tags. Recording every defect in the issue log, including those resolved on the same day, provides a root cause history that is essential for future troubleshooting. Standardized file naming conventions allow raw data to be retrieved instantly during a crisis. Linking the date, level, and system to the file name ensures the evidence chain remains accessible. Ready for service is a milestone reached only when every technical and operational prerequisite has been documented. The systems manual functions as the operating memory of the project, detailing the procedures for normal, maintenance, and emergency modes. Operator training is valid only when staff can physically demonstrate fault isolation and dashboard proficiency. Classroom attendance alone does not constitute operational readiness. The go-live decision depends on 4 factors: safety, operational control, failure tolerance, and spares availability. These must be confirmed before onboarding any IT load. No evidence, no acceptance. No prerequisite, no next gate. A data center is commissioned only when the raw evidence proves it can be operated, maintained, and recovered.